Hello, everyone. Thank you so much for joining us today. We're very glad that you're here. I do have some announcements before we get started. Some upcoming talks and webinars. On Tuesday, April 9th, we'll have a webinar on exposure to cleaning chemicals and disinfectants in Latina house cleaners with Dr. Homero Hardy in the New York, New Jersey Education and Research Center. On Wednesday, April 17th, we'll have Occupational Ergonomic Research in Pacific Northwest with Dr. Jay Kim in the Northwest Center for Occupational Health and Safety. And on Tuesday, May 14th, we'll have Building Inclusive Spaces in the OEHS profession with Laura Danielle Cavamontes Barrientos and Molly Murphy in the Center for Health, Work, and Environment at the Colorado School of Public Health. To see these webinars, you can visit us online at coeh@berkeley.edu/aboutce. I'm also happy to share an upcoming event at UCSF on climate change and health, the threat of harmful algal blooms, and that will be with Dr. Gina Solomon on Wednesday, April 10th from noon to 1 p.m. And I'll put information about that in the chat at the end of today's webinar as well. So on behalf of the Center for Occupational and Environmental Health, it is my absolute pleasure to welcome you to today's webinar, Climate Change and Human Health, an Alaska Perspective with Dr. Jeffrey Demain. A few more housekeeping announcements. Today's webinar is a little bit different. If you're one of our regular attendees, you may have gotten used to our hour-long format. But today we're happy to make continuing medical education credit available for this presentation, and we've also extended the time. So we'll be going through 1:30 p.m. Pacific today. Similarly to our regular webinars, all participants who log in with their registration email for the full live presentation will receive an email tomorrow within a link to the evaluation form, and that'll qualify you for a certificate of completion for 1.5 continuing education contact hours. We will be manually creating the certificates this time with the CME credit, so please give us a little bit of time to make your certificates for you. You'll receive them as an email PDF within 5 business days. You're also going to be muted during this presentation, so if you'd like to ask a question, please enter it into the Q&A. And we will have plenty of time at the end of the presentation to address as many questions as possible. This presentation is being recorded and will be made available on the Center for Occupational and Environmental Health YouTube page within 5 business days. And it's my pleasure to hand it over to Dr. Dennis Schusterman, the chair of our Continuing Medical Education Committee, to introduce today's speaker.
Thank you, Michelle. So we were discussing earlier, this is kind of a momentous moment for me because I first heard Dr. Demain speaking at an allergy meeting roughly 10 years ago. And it definitely changed my perspective in terms of identifying with the consequences of climate change. And I'm not going to upstage him in terms of the content of his slides because it includes many of the same slides that influenced me. But I will speak a bit about the concept of a tipping point. So the fact of the matter is that for those who live near the Arctic Circle, the effects of climate change are more measurable and visible than they are for those of us who live in temperate climates. And Dr. Demain will go into that in some detail. But the notion that there could be changes that would be foundationally inconsistent with the continued primary economic model of subsistence in Aboriginal peoples is one that for me is profoundly saddening. And I think you'll find out why it has that effect as Dr. Demain speaks. So Dr. Demain is a clinical professor at the University of Washington, an affiliate professor at the University of Alaska. He's on the Board of Regents of the American College of Allergy, Asthma, and Immunology. He's on the board of directors of the American Board of Allergy and Immunology. He's the founder of the Allergy, Asthma, and Immunology Center of Alaska, and a founder and medical director of Lux Infusion and Immunology. So with that, I'm going to turn it over to Dr. Demain and let him share his slides with you.
Thank you very much, Dr. Schusterman. I want to thank you and the Center of Occupational Health and Occupational Environmental Health at UC Berkeley for this invitation and the organizers that have put this together. Also, big thanks to Michelle Myers, who's been wonderful to work with in coordinating this program. Typically, I discuss impacts on respiratory disease and allergic disease really throughout the world, and mainly looking at greenhouse gases and how those are having impacts. Early on, I did speak about Alaska really as a bellwether of what we're seeing. So I'm getting out of the weeds, so to speak, and kind of taking a 1,000-foot view. And we're going to look at the many areas that Alaska, particularly Alaska natives, are being significantly impacted today, not in the future, but today from climate change. So thank you very much for having me. So let's get started. So for disclosures, I think the only one that's relevant here is that I am not a climate scientist. These are other financial disclosures, but are not relevant to this talk. So let's talk. I'm just going to lay a little groundwork for climate change. I suspect all of you have an understanding of it. But climate change is occurring, and science has made a consensus that it's occurring and the planet's warming. It's primarily due to the atmospheric gases, carbon dioxide, nitrous oxide, and methane that have been increasing since pre-industrial age, and they're directly related as drivers of our warming climate. The greenhouse effect is real, and a good thing. It's because of the greenhouse effect that we have an inhabitable planet. If we didn't have that, this planet would be a planet of ice. So what's happening is really more an enhancement of that greenhouse effect, where you have infrared radiation that's being stored and heated in these molecules that's further heating the surface of the planet. This leads to more extreme weather events, rising sea levels, and changes in precipitation patterns. This was a really great cartoon that I found. It was from the National Park Service, actually, that shows the normal greenhouse effect, where you have UV radiation that's coming in, and some of it's being absorbed, but much of it's being reflected back, principally by sea ice, glaciers, and then some of it's going to be trapped, and it's trapped in CO2 and the other greenhouse gases. But as our greenhouse gases have increased, then you have more and more of that re-radiated heat being trapped and held in our troposphere, causing the significant rise. And I'm going to try to show you that this is a compounding effect, because as we lose sea ice and glaciers, now we start absorbing more and more heat and CO2. And with the re-radiated heat, as our greenhouse gases go up, we're going to start heating our atmosphere even more. So CO2 has risen from 280 parts per million pre-industrial time to 420 today. The global temperature has risen 1.18 degrees C, 2.1 degrees Fahrenheit since 1950. In the Arctic and subarctic, it's risen 3.1 degrees C, or 5.6 degrees Fahrenheit. So we have fallen. This is beyond what has been termed the tipping point. The 10 warmest years in history have occurred in the last decade. And what's projected globally by 2100 is an additional 4 degrees C, or 7.2 degrees Fahrenheit. Now, on the bottom corner, you can see modeling. So the modeling is depicted in a fair variety, because we don't know what kind of steps we're going to take. At the worst, if we do nothing, you're going to be in the red line, and that's where you're going to see that 5 degrees Celsius, or 8 or 9 degrees Fahrenheit. But the modeling is also showing that we can make changes, and if we do make changes, hopefully we'll be down in the green or the yellow. This is a really interesting. This is from the NASA. I'm going to let it play twice. So this is temperatures changing since 1880 to current. That's pretty impressive, looking at not only summer temperatures, but winter temperatures throughout the year. So anyway, I thought that was really quite a visual. So this 2023 was the warmest year on record. When you're seeing the darkest red, those are all record warm temperatures. And then the next color, which makes up the vast majority of the planet, are much warmer than average. There's a few little areas that had actually cooler than average temperatures in the southern hemisphere, and that's partially due to what level of sun exposure there was because of cloud cover, atmospheric circulation patterns, etc. Now, this is from the sixth assessment from the IPCC, and it was very interesting. So when you look at solar, which is red, there's really been no change in solar activity. The brownish color is volcanic, and if anything, the volcanic activity has decreased, not increased, over this period of time. Now, in the yellowish color on the bottom, that's aerosols. So we banned chlorofluorocarbons, and once that happened, we actually had a positive impact. So you can see positive impact can occur on temperature with modifications. Now, the green up top, that is mixed greenhouse gases. So that has, without a doubt, the most impactful effect on our temperature. And the temperature is denoted with the black line, and the purple running through it is anthropogenic and total impacts. So the World Health Organization stated that climate change is the single biggest health threat facing humanity. And that was November 2nd, 2023. And this is associated with air pollution, disease, extreme weather events, forced displacement, food insecurity, and pressures on mental health. And they estimate 13 million people currently are dying every year as a result of some of these environmental factors. So we're going to address these factors today. We're going to look at urban heat. We're going to look at air pollution and air allergens. We're going to discuss insect, waterborne diseases, water resources and food supply, and mental health. So these are all impacting Alaska right now. So let's talk about Alaska. Let's first do a little geography lesson. The mainland Alaska is 55 miles from Russia, and then Alaskan territory to Russian territory is actually 2 miles. So you have Little Diomede Island, which is Alaska or US territory. Big Diomede Island is Russian. This is Diomede, the village of Diomede. It's an Yamukyak Indian village that really live predominantly on subsistence, mainly with fishing and sea mammals. So when we're looking at this map, the red, that is the road system of Alaska. So you can see that the majority of Alaska is not on the road system at all. So they're dependent on sea, rivers, four-wheelers, snow machines, and boats. 86% of the communities of Alaska are off the road system. And Alaska makes up basically 40% of all tidally influenced shoreline in the US, greater than 46,000 miles. So again, when we're looking at erosion and sea level rise, a very significant impact on the state. If you lay Alaska across the continental United States, the tip of the Aleutian Islands will touch San Luis Obispo, and the southeast will touch Jacksonville, Florida. Alaska makes up 1/5 of the continental United States landmass. So when we look at the temperatures in Alaska, and this is in the past 50 years, so you can get a sense of how much temperature rise we have. And the higher the latitude, the greater the change. In the past 50 years, Alaska has risen 4.3 degrees Fahrenheit, but winter temperatures have risen 6.4 degrees, while the planet has risen 2.1. So Alaska temperature rise is about 3 times that of the global temperature, and it's projected to rise to 8 to 14 degrees Fahrenheit by the end of the century. So this is having dramatic impact throughout the state and the ecosystem. So let's first talk about permafrost. Permafrost is in the rock or soil that stays frozen for 2 years or more and is found beneath 80% of the ground in Alaska. And it's one of the planet's largest terrestrial carbon sinks. So that's an important point as well. So permafrost actually is a carbon sink. As the temperatures increase, we're having thawing permafrost, which releases methane and carbon dioxide. And obviously those are contributing to further climate change. So methane is responsible for 30% of the current temperature rise, because these molecules will capture re-irradiated heat, and that'll hold that heat and generate heat, warming the troposphere. So even though the methane is only 16% of the greenhouse gas, second to carbon dioxide, it represents 30% of the temperature rise. It has 84 times greater at trapping heat than CO2. However, methane is going to disperse at around 12 years, where CO2 is going to disperse after hundreds of years. So permafrost thaw leads to land caving, sinking, which damage infrastructure, roads, and buildings. So this is now creating a situation where there's about a dozen villages right now that are in the planning of moving, or certainly studying that. So 2 are in the process of moving currently, and 4 are actively planning. And you can see on the image on the top left, because of permafrost loss, the road system in Denali collapsed last year. So cutting off half of the road system for tourists. So in melting permafrost, you can see the infrastructure damage is profound. These homes are literally sinking into the ground, essentially creating almost like sinkholes would be the best example of that. Also, the permafrost, once it melts, you have a lot of water, and it becomes, you can't really walk on it. It becomes marshland. So there's a lot of adaptation that's having to go on. And the ice road truckers is the real thing. So at the peak, the ice road truckers had 120 days per year to get goods and supplies up into northern Alaska and western Alaska. Well, now that's down to 90 days because of the decrease in the ice road stability. This is Dr. Vladimir Romanovsky. He's the head of the permafrost laboratory at the Geophysical Institute and University of Alaska Fairbanks. And I'm going to have some of his slides coming up soon. This is the University of Alaska Fairbanks, a very science-forward university, great emphasis on environmental science. Other things with permafrost is cold storage. So this is typical. These cold cellars is how foods were preserved because they're frozen year-round. But what's happening, these cellars are now thawing and refreezing, thawing and refreezing. And this is what they're starting to look like. So they're becoming unusable. And what's also happening, because these cellars are warming, when you reach 39.2 degrees Fahrenheit, you start seeing Clostridia botulinum toxin. And Alaska right now has the highest rate of botulism in the United States, partially as a result of this. Now, this is really incredible. This is from Dr. Romanowski's lab. This was looking at Alaska, then the blue represents frozen ground or permafrost in 1890 to 1889, 1880 to 1889. Now, just keep your eye on that. This is now 2000 to 2009. Let's do that one more time. That's really pretty impressive. I would imagine right now there's a lot more red. I really searched to see if they have updated this, but it looks like they're doing it about every 20 years. So hopefully we'll see it here in a few years. So Mike Brubaker works with the Native Tribal Health Consortium. He's a great guy. We've done several programs together, but he did research looking at the Alaska Native villages and studying these effects. So I'm going to use his findings throughout this talk. So his findings on permafrost is warming soil is thawing traditional food cellars, health concern, reduced subsistence food supply, increased foodborne illness, also damage to homes and infrastructure. Projected 20 to 50% increase in active seasonal thawing, and potential adaptation is baseline mapping, monitoring, and ultimately finding alternative ways of storing food. So now let's talk about erosion a little bit. Permafrost plays a role in that as well. In fact, if you look on the right, that actually is a combination of permafrost loss along with rising sea levels, and most importantly, melting sea ice. When you have melting sea ice, now you have waves and storms. Where the sea ice protects the coast, the storms and waves are creating significant erosion of about 150 feet or more per year. So this is the village of Kipduk, and in that village, a population of about 500 on the Bering, 100 miles west of the Bering Sea, is also being impacted by these factors. This is the village of Nutuk. Nutuk right now is one of the villages that's currently in the process of relocating. But as you can see now, that you can see actually homes that are right at the edge now of the erosion. And there have been many efforts trying to sustain and improve seawalls, but it's not been very effective because of the force of the waves and the storms. And actually, you can see little blue dots around. A lot of those blue dots are indeed those ice cellars covered with blue tarp. So sea level has been rising since 1880. In fact, it's risen about 10 inches throughout the world. The orange is trend lines based on tidal gauges, and then the satellite imagery is the kind of in the green line, and both parallel. So the IPCC is now projecting that by 2100, the further rise of 100 centimeters. And this is something that's not only affecting Alaska, of course, this is affecting all tidally influenced areas throughout the world. And about 30% of the population of the United States lives in tidally affected areas. And throughout the world, it's approaching 40%. So this is the village of Shishmaref, and you can see the building really falling into the sea. I have another one, I couldn't find it. It was on Unalakleet, where the erosion has right up to the edge of the airstrip. That's Barter Island, and then there's another image of Newtok. So erosion with loss of sea ice and rising sea levels, the delay in shore ice, sea level rise, thawing permafrost, and storm activity resulting in rapid erosion of all the coastal areas. Health concerns are critical infrastructure damage, including airports, roads, and coal cellars, and as a result of that is injury as well. And then projected is increased rate of shore and riverbank erosion, and growing navigational hazards on the river. Again, the river is a key source, winter or summer, for navigation and transportation among the villages. And when you have giant hunks of land and rock that are falling into the river, that's creating a very hazardous situation. And potential adaptation, again, shore and river monitoring, erosion mitigation measures that, continue working with that, injury prevention, and ultimately relocation. So this was from the IPCC special report on ocean and cryospheric change in climate in 2019. It's just showing that the snow cover being melting, glacial mass melting, sea ice melting, the Greenland and Arctic mass melting. So you have rising sea levels, warming of the marine heat waves, warming of the ocean in general, lowering pH because of absorption of CO2, and lower oxygen within the waters. And this is not only affecting Alaska, through ocean circulation, the ocean is basically transmitting or equalizing heat throughout the globe. That's one of the main reasons of the ocean currents, is to do this. The green represents deep sea circulation. The red represents this more surface circulation. Now let's move on to glaciers. This is Portage Valley. It's actually one of my little playgrounds, about 20 minutes from my house in Girdwood. And on the left is the railroad tracks. On the right is in the valley of the road. And then the center is Portage Creek, where we do a lot of rafting and fly fishing for salmon. This valley has 4 glaciers, and the largest one is where in the background, where you see the glacial lake. When I moved to Alaska, the glacier was not up to the edge of the road, but very close. This is a photo in 1914, where you can see the glacier extends all the way to the landmass, so a terrestrial glacier. In 2004, a parallel photo was taken, and you can see now that the glacier is barely visible. So it's losing 5 kilometers since 1939, and it's losing about 150 meters per year. At the edge of the land system, this is where the road and the railroad come together. This is a 1-lane road, so to speak, that's shared with the railroad. So on a half-hour, cars go in, on the hour, cars come out, and then 6 times a day the train travels. This is the longest continuous tunnel in North America. On the other side of this tunnel, the western shore of Prince William Sound and the harbor town of Whittier, I think on the one sunny day a year. So receding glaciers, they're melting twice as fast now as they did from 1960 to 2004. And 70% of this ice volume loss is land terminated glaciers, not so much due to the calving that you see. The ice loss is going to increase over the decades to come. This is in addition to losing the ability to reflect the sun back and as a consequence absorb more sun. It's also altering the stream flow of Alaska. So it's altering the waters in a couple of ways. Number one, you've got a lot of fresh water going into the salt. Number two, you're warming the waters as well because it's absorbing heat, and that's altering the cold water species like salmon. So it's really impacting salmon returns, which again is key to the subsistence of these peoples. And then there may be with this also. There's also with glacial receding, you have now a lot of glacial silt that's being released into the air. So it's fine particulate matter. It's associated or maybe associated respiratory disease. Interestingly, it's not been studied. Additionally, glaciers like sea ice absorb pollutants or freeze pollutants in. As they melt, those pollutants are also released. So let's look at the ice pack. This is if you look on the left where it says 1985, the bottom right is Greenland, the bottom left is Alaska, and the top left is Russia. And this is looking at 1985. The white and the light turquoise represent multi-year sea ice. The black represents essentially seasonal sea ice. So you look at the difference between 1985 and 2021. So you now have majority is just seasonal, basically winter sea ice that thaws in the summer. So significant impact. Some of the data from September minimum in 1980 was 7.5 million square kilometers, 2007, 4.2 million square kilometers, and 2020 is 3.8 million square kilometers. So in total, it's lost over 1.1 trillion tons of that one ice pack. And worldwide, there's been 28 trillion tons lost. So as we see the decline of the sea ice, you can see there's ups and downs and ups and downs. When you have that up, that's back to seasonal ice, and you've lost that multi-year ice. So again, kind of looking at that ice pack in 1985, 35% of that ice pack was single or seasonal ice. Well, today it's 70%. So you've lost that multi-year ice. So I don't think it'll be very long before this becomes literally just all seasonal ice. So when we see that this is the sea ice extent and thickness that has decreased substantially, again, we talked already about how it reflects back sunlight. So now it's going to increase water temperature warming because of absorption of heat and acidification because of absorption of CO2. With the loss of sea ice has had a direct effect on both coastal flooding as well as storm surges. So with the warming water and more water, not ice, this is vaporized into clouds and it creates much more storms. And then I'm going to show you the impacts of those storms coming up. So a lot, again, because of this loss of sea ice, it's also impacting the ability to subsistence hunt for animals as well as for humans. So this is creating a significant change in pattern of behavior. One of the issues is you're seeing a shift to stay with those colder waters and where the food is of fish that are harvested. So commercial fishing is shifting further and further north. So the commercial fishermen are having to travel more distance into more dangerous waters and outside of Alaska waters into international waters where they're competing with the Russian and Japanese commercial fishermen. So again, Mike Brubaker's summary of sea ice has been forming later in the fall and departing early in the spring. Multi-sea ice is being replaced by thinner first-year ice, shorter seasons of over-ice transportation and ice-based hunting, and disruption of sea mammal harvest, and increased vulnerability to coastal erosion and ice-related injury. This is a picture of whaling. Now there's 11 whaling communities in Alaska. They've done this for hundreds and hundreds of years. It's overseen by the Alaska Eskimo Whaling Commission and very tightly regulated by the International Whaling Commission. The quotas are very strictly maintained just to provide nutritional and cultural need for those 11 communities. It's also going to be based on the growth and size of the bowhead whale population, and they're not in danger. I can say that. The other thing that's happening, I mentioned it earlier, is the salmon return. So the Yukon River has been a tremendous source of subsistence for many, many, many villages. And actually, virtually every river in Alaska has salmon return. And all these villages live on rivers, and they really rely on salmon for a significant part of their subsistence. So the salmon you can see on the top left are in smokehouses. They're smoked and dried, and that's how they're preserved, and that's their food for the year, for the most part. Well, the last 3 years, the Yukon fishery has essentially been closed, certainly to commercial fishing. The Alaskan parks opened it up for subsistence only for certain periods of time. Believe it or not, that just went to court, and in the federal court, and the federal court said, if we close the river's closed. Subsistence fishing cannot happen. So I don't know what's going to happen to these communities. But anyway, this is terrible. So river ice breakup is also occurring more quickly, and as a result of that, you're seeing more and more deaths. That one, the one up on the top, just happened December of 2023 in Eagle River, where a woman and her dog fell into the ice and were swept away. But in rural Alaska, it's even a bigger deal because they rely on the ice for transportation and for the transportation of goods. And without that sea ice, there is no goods that are going to come in. And as a result, it's less predictable. And you're seeing snow machines fall in, people fall in, trucks falling in. Here's one, just an image that a father and 2 sons just recently died falling through the ice. So you also have further flooding with sea ice breakup or river ice breakup. That you can form ice dams. This is Nome. It actually was flooding season when there was a breakup of the sea ice of the Snake River. And the next image is Galena, breakup of the Yukon River. What happens is it breaks up too early. Then you have water, very forceful water pushing, but it's not broken up completely. So this ice will kind of collect at an isthmus and create essentially a dam. And when this damming occurs, you have flooding that's just tremendously impactful to these villages. This is Napakiak, and you can see now this is the Kuskokwim River. It's now 64 feet from their school. So again, another village that's going to have to make adaptation. Now, this was from NOAA, and I thought it really summed things up pretty nicely. So I'm just going to kind of put it all into one picture. You have rising sea level, you have melting sea ice, you have waves that are now occurring, you have swash, which is going onto land and taking out the shoreline. Because of the warming water and more open water, you have more rainfall. You have storm surges as a result of the more rainfall. It disrupts river flow, and it raises groundwater, and then you have land sinking because of the rising water as well as the loss of permafrost. So this is a rather dire situation. Precipitation has also increased. Everything you see in green has increased over this 50-year period. The darkest green is 55% or more. When you get a little less dark, it's in the 35 to 45% more, and then down to the 15 to 25% more. You do have a few areas where there's actually been drought, some in the western interior or eastern interior Alaska, and then down in south central Alaska, and that's having an impact as well. With these increased storms, you actually increase respiratory disease. Pollens, these storms occur predominantly, in the summer when at its warmest. So pollen grains, grass pollen grains are pulled up into the clouds. The osmotic effects plus the moisture cause these pollen grains to rupture, releasing allergenic fragments. These fragments are less than 2.5 microns and penetrate deep into the lungs, causing really severe respiratory illness, severe respiratory allergic exacerbations. This was an interesting study. One of my favorites, actually. There's many that have looked at this, but I like this from Wagga Wagga, Australia, where 55,000 population. You can see on the bottom, the rainfall starts, then you see the wind direction shift, the wind really pick up, and then you have an 8-fold increase in the amount of pollen. The clear circles are pollen husks that have ruptured and released fragments. The dark is intact pollen. This is an image of some of the pollen releasing those fragments. So during that one storm, 215 asthmatics presented to the emergency room with severe asthma exacerbations. 41 required admission to the hospital. And just during this storm alone was greater than a fourfold standard deviation increase. So just to kind of reemphasize this, there's a pollen grain on the top. The grass pollens are about 25 to 35 microns. The fragments are less than 2.5 microns. It provokes a very significant IgE-mediated antibody response. So a big allergic reaction and, again, severe event. The factors that induce it are thunderstorms, as I mentioned, high relative humidity, and heavy rainfall. What also happens is these pollens will aggregate with carbon. So that causes this aggregation, and now they're inhaling these allergenic pollens with aggregated carbon, which is triggering a different type of immune response. So you have a very intensified event. Now you say, how much thunder and lightning can we have in Alaska? This is a 2-week period where tens of thousands of lightning strikes. And this was in June and July, right in the middle of the grass pollen cycle. So it can be quite significant. And this is occurring more and more frequently because of more storms and because of rising temperatures. So when you have water, you're going to have mold. And so the homes in Alaska don't have central air. They don't have HVAC systems. They're most often heated with stoves. And so the molds can easily accumulate in homes. There's actually not a lot of robust data looking at molds as far as sporulation with heat and with CO2. There was one in the UK looking at, it was a retrospective study over 27 years that showed a significant increase in the number of days where cladosporium spores exceeded allergenic concentration, and it's statistically correlated with temperature. There was a study, there was a very nice study actually looking at CO2 where all the variables were controlled, but CO2 was increased from 400 to 800 parts per million. And what it identified was a 40% increase in the mycelial colonies. But what was determined was that it was mainly due to a change in the carbon-nitrogen ratio. So when it's greater than 30 to 1, it slows the decomposition. We could spend an hour just on that because that's impacting the allergenicity of pollens, that's impacting the nutritional value and protein content of many foods, particularly grains, but that's outside of this discussion. So clearly it's been demonstrated that mold, interior mold, causes significant respiratory allergy and asthma. So what are some of the health effects? Allergic reactions, probably the most common. Nasal and eye symptoms. Allergic fungal sinusitis can be quite severe, where the mold is actually colonized in the sinuses. Asthma exacerbations, more severe asthma, very difficult to control asthma when we're dealing with molds. And allergic bronchopulmonary aspergillosis, again, where these ambient molds become colonized within the respiratory tract. So the individual now is walking around with their own allergen inside. Hypersensitive pneumonitis is a very severe immune sensitivity. It's not allergic. It's mainly an IgG-mediated event with more neutrophilic inflammation, but again, quite severe. Opportunistic infections, people that are immunocompromised actually can become infected with what we consider ambient mold. Then the mycotoxic effect, that's kind of that black mold effect. That's anecdotal at best and certainly controversial. It's doubtful that that's real unless it's just profound exposure. So when we look at the health effects in general of intense storms and flooding, this is also Mike, increased death and injuries, water damage and resulting in mold and respiratory disease, rupture of pollens, as I've discussed. You have water and foodborne diseases as well, loss of homes, ecosystem and economic impacts, displacement of families, and significant stress and mental health issues. So now let's go the opposite. What about areas where this drier? Well, there was an infestation of now spruce bark beetles, and they had a similar problem in Colorado with pine bark beetles. But spruce bark beetles impacted 4 million acres on the Kenai Peninsula. And it's really striking how rapidly this can occur, and these trees will die. So we talk about our pollen map here. This is one of the areas of the drought that we talked about. So the drought and the heat play a significant role in the invasion of these beetles that are killing these trees. This is in Cantwell, about 70 miles south of Fairbanks. So if you look on the left, this is a boreal forest. It looks like it's in good health, but they identified that there's evidence of the spruce bark beetle. If you look on the right, that is the following year. 90% of the trees are now dead from the spruce bark beetle. And so it's really incredible. And this is a tremendous fire hazard on top of just really wiping out just huge forests. So the black on the map is where the spruce bark beetle is, and the red is showing areas that are climatically favorable to the beetle. The beetles bore underneath the bark. They lay their eggs, the legs, the pupate, and the tree spends the fall trying to patch these holes. So it puts a lot of energy into trying to cure itself, and then it dies over the winter. It can't survive the winter. So the following spring, they're dead trees, and it's remarkable how fast that happens. So then wildfires are also a big problem because you have these just acres and acres and acres of dead trees. So forest fires can easily occur. We have between 600 and 700 forest fires every year in Alaska. And with that, of course, there's smoke and 2.5 micron particles that can penetrate very deep into the lung. There's greater impact on human health because you have with the smoke, it can also bind with the pollen and again create that aggregate that I was talking about. So in addition to respiratory disease, you have cardiovascular disease. Now, not to mention, of course, the fact that you're destroying the landscape. People are going to be injured or killed from the fire itself and the destruction of a lot of infrastructure. Now, this particular fire, this is all real. This is on the Kenai Peninsula. And this is exactly where I was showing you where all that spruce bark beetle were. So there's my precipitation map, and you can see that area. But this fire was 150,000 acres, and this is over a valley that is probably some of the most pristine fly fishing in the world. Is the Kenai River, all native rainbow trout. And Cooper Landing is kind of the headwaters of that. So this is where all the trips are launched out of, and we have property there. So we were watching this fire come toward us at 3 different directions, and it was jumping roads, jumping the river, jumping mountains. It was the most incredible thing you've ever seen. But the fire was eventually controlled. But for the remainder of the season, this is what our valley looked like. So there was absolutely obviously no fishing, no travel, but it was devastating. But you can imagine how high the PM 2.5 count is there. There's another fire called the Boundary Fire that occurred initially in Canada, and it swept toward Fairbanks in the interior. It burned over 500,000 acres, and a lot of that's tundra. And so when you have burning tundra, that burns for years. So you can stop fires, but with the trees from spreading, but the tundra, it will just sit there and smoke and continue to burn. So when we talk about hazardous air, the worst air quality is hazardous, and if that's greater than 300, well, around Fairbanks that exceeded 1,000. So people had to literally leave; they couldn't stay there. Oh, I missed something. We lost. I'm sorry. I had some nice images, but I don't know where they are now. Okay. This was during that year. It was about 300 miles south of Fairbanks. I was up in my friend's 187 taking photos, and so the smoke just permeated the entire state. Oh, here we go. Here's Fairbanks. There's an image of Fairbanks on a corner. And that's the exact same corner that I took those pictures. And, you can just get an idea of the difference in the air quality and how impactful it is. So now we're going to move a little different. This is a program called the Scenario Network for Alaskan Arctic Planning. They recently added Arctic to it. And this is a modeling research. And so they're looking at historical and current things. And they may be looking at trees or looking at shoreline or looking at glaciers. And they do modeling and modeling projections. So it's a wonderful program, and this is run by Dr. Scott Rupp at University of Alaska Fairbanks. So this was looking at vegetation, which is important, and this is what their modeling was demonstrating, is the green represents conifers like spruce, the brown represents deciduous trees like birch, for example, and around a little about 2020, they were anticipating that you're going to have a predominance of deciduous trees instead of conifer trees. Now, part of that can be fire, but a big part of that is environmental change, such as the melting permafrost. So what's the difference? Well, deciduous trees, number one, that's the pollens. That's where you have the respiratory disease associated with asthma. And that's going to cause hay fever and other issues as well. So that's going to be that issue. But secondly, the conifer trees, although the pollens are not a problem, the conifer trees are a good CO2 sink, whereas deciduous trees, not so much. They're going to have a seasonal ability to absorb CO2, but whereas the conifer trees can do that throughout the year. So that's going to have further impact. This was a nice paper, actually. This was published by Abigail Swan in 2010 in the Proceedings of National Academy of Science. And I say that because she was doing her postdoc at Berkeley when this was published. And what the point was trees are invading the Arctic. And so they're looking at Denali Park in the Brooks Range. And her study was looking at temperatures, how it's changing the tundra. And we're seeing trees develop in the areas that trees were not. Well, this just came out. In fact, you can see March 11th, 2020, I caught wind of this study, that trees are expanding in North Alaska's Arctic. Now, this is beyond now the Brooks Range. So we're over those mountains. These mountains that you just saw, we're on the other side. Now we're looking out toward the Arctic Ocean. And you can see that the trees or the forestation is occurring there. And why this is occurring is interesting. Originally thought to be predominantly temperature, but it has more to do with the loss of sea ice. With the loss of sea ice, you have more storms. With more storms, you have more precipitation. With more precipitation, that's not just rain, but it's snow. And the snowpack is allowing these trees to mature and grow and protect them because snow is insulating. If you don't have snow and it's -10, it's -10. If you have snow, it's 32 and it's 32. So underneath that snowpack. So this is allowing a significant change in the ecosystem. This is looking at a study by Len Belleroy and Lou Ziska. He was at Duke at this time. And they looked at pollen counting stations kind of up in latitude. So from Nebraska up through Saskatoon, Canada, the length of pollen season, the ragweed pollen season, was extended by 27 days in this 14-year period. When you look at first frost, meaning, when is it going to occur? The first frost is occurring later. So up to 18 days later. So meaning it's later in the year. So you have a longer season for growing. And then first frost free is occurring up to 20 days earlier. So you can see there's just significant changes in the growing season, so to speak. And then the EPA took this data and added another 4 years. And with that additional 4 years, they found the length of season increased by an additional 3 to 5 days, kind of giving you an idea that this is kind of a compounding effect. Now, this is a very robust study. Also, Lou Ziska involved in this one, published in Proceedings of the National Academy of Science in 2021. He's at Columbia now. And so you looking at using 57 North America stations called the National Allergy Bureau, plus 2 stations in Alaska, one of those is ours, and 1 in Canada. And this was over a period of 1990 to 2018. So on the A is looking at annual pollen, and you're seeing that the pollen has increased over that period of time. Spring pollen is C, and you're seeing spring pollen has increased. And that pollen start date, which is B, is significantly earlier. and then season length is in D, is significantly longer. So this is just globally looking at pollen throughout the United States. So this is something that's not occurring in one local area, but occurring throughout. Now, again, I could spend an hour on this slide alone. So you got increase in faster plant growth, increase in plant height and biomass, increase in pollen production, increase in allergenic peptides and pollen, earlier and longer pollen seasons, and higher latitudes are being more affected. So kind of to sum up a few high points on air quality and airborne allergens, increased forest fires and tundra fires create smoke, which are bad for the lungs and the heart. Increased levels of airborne allergens are going to significantly impact people with environmental allergy. Respiratory disease is going to get worse and greater exacerbations, not just from the smoke itself, but also mercury that's being released from the soil and from the fire. And our future projections are greater amount of smoke and more respiratory disease, greater release of mercury, increased pollutants, including the glacial silt that I mentioned from retreating glaciers, and continued increase in airborne allergens. So let's move on to a little different topic and talk about insects and water and foodborne illness. This is a nice study done by Joe McLaughlin. Prince William Sound is a beautiful, beautiful estuary, and because of continuous cold water, it's a perfect place to have oyster farms. So, but as water is warming, if the water gets above 59 degrees, you start seeing algae and copepod proliferation. Well, within the copepod and algae proliferation, you'd have harboring Vibrio parahemolyticus. So that's what happened. So you can see the dotted line. The dotted line is when the temperature rose, of the water temperature rose above 59 degrees or 15 degrees Celsius. And with that, you see the cases of Vibrio parahemolyticus in patients with, that ate the oysters. And this is a very severe gastrointestinal disease. This is also occurring, and I've been working on this, and hopefully we'll get a paper published soon. We're seeing with warming waters also that the fish are becoming more impacted by a parasite called Anisakis, and it's a nematode. Now, Anisakis we're not a host to that, but what Anisakis does is if you eat it and you're eating raw, you have to eat the raw fish or very undercooked fish. If the nematode is alive, in the gastric mucosa, it'll bore a hole. And when it bores a hole and tries to literally go through it, it triggers a very severe immune reaction on IgE-mediated hypersensitivity. So subsequent to that, all you have to do is see the peptide, and it causes severe allergic reaction, resulting in gastrointestinal symptoms, drop in blood pressure, and anaphylactic shock. So in other words, even when the fish is thoroughly cooked, if that fish had the Anisakis worm in it, the peptide is there and it can trigger the event. And you can kind of see the life cycle. The fish release release the eggs, and then they become embryonated, and then into the larva form, which is ingested by the crustaceans. The fish eat the crustaceans, and then humans eat the fish. So I've seen, well, at least a dozen cases of that. So changing patterns of insects, we're seeing that in Alaska. This is lepidopterism. So a lot of insects, caterpillars, they have venomous spines. What was this? It came out in the paper that berry pickers were experiencing these really significant rashes. Let's see, there we go. And they're really telltale. They kind of match up with the particular caterpillar. So we identified it as a tussock moth. And not only can it cause significant rash, it can also cause systemic symptoms. So it can develop fever, joint pains, and even really general allergic type reactions. There's been severe allergic reactions associated with it for people that are logging. So loggers that'll breathe these spines into their lungs. But when it's just on the skin, it doesn't really occur that much. Also, increased Hymenoptera. So in the number of Hymenoptera in Fairbanks estimated to increase by 10-fold. So one of the Jack Whitman, a biologist, trapped about 3,500 yellow jackets in 3 homemade traps. They were soda bottles with whitefish in it as a bait. And that was within a week. And then went on to destroy 9 aerial nests and estimated about 12,000 yellow jackets. And this pattern was seen throughout Alaska. In addition, we got the reports of the first 2 deaths from Hymenoptera stings within 4 weeks of each other in Fairbanks in the summer of 2006. So Brad Gessner and I wrote this up, and we published it in the Alaska Epidemiology Bulletin. And then we put together a team with 2 epidemiologists, an entomologist, a pediatrician, and myself to research this. So we looked at temperature during this period of time. And then we used 3 databases. The most important one was the Medicaid database, which we were given access to, which was 132,000 lives. So we broke it up based on zip code into the 6 epidemiologic regions of Alaska. So we wanted to study each of those regions independently. So when we looked at those, what we found is that the further north, the higher the incidence of people seeking care or urgent or emergent care for insect stings. And you can see as we got up to the most northern area, which is Barrow, now called Ukiagik, 626% increase. The one area that did not meet statistical significance was Kodiak, but you can see they had the least change in temperature. So when we did our data, the temperature had the biggest impact. Most importantly, it correlated with the winter temperature increase. And what our conclusion was is that there was likely, because of increased snow, there was enhanced overwintering of the hibernaculum and therefore more colonies in the spring. And Derek Sykes was instrumental. He's an entomologist at University of Alaska Fairbanks. And when we did this talk, I looked at the current map that I showed you earlier of the temperature, and this is the old temperature map that I used because of the time frame that we were studying. So you can see really pretty significant differences, especially in the most southern and the most northern areas. So within 16 years, we're seeing changes like that, which is really quite frightening to me, meaning that our predictions might be maybe not as good as we thought, maybe worse. What about tick-borne disease? Well, Alaska has not at this point had a human tick-borne disease that started in Alaska, although we have become hospitable to ticks. We have animal ticks, dog ticks, we have moose ticks, we have hair ticks. So this is something new. When I moved to Alaska 30 years ago, there were no ticks. In Norway and also in Sweden, they've been studying and tracking the Azoxides tick. This is associated with Lyme disease. And that they're documenting that now, so in the Arctic, but it's not been in Alaska yet, but it's very hospitable to it. So this is the moose tick. They call it moose winter tick. So they get infested with the ticks and basically lose their hair, and they can't survive the winter without their hair. And they can have so many ticks that like a moose calf can get exsanguinated. So we've been looking at distribution of insects really throughout the world. We're seeing mosquitoes and plant communities that are migrating to higher ground as permafrost thaws and glaciers retreat. But this is happening all over the world. We're seeing dengue fever and malaria in areas that never had it because, again, mosquitoes are able to shift very quickly as the ecosystem changes. We talked about the beetle-plagued forest in Alaska that's occurred because of rising temperatures, and in this case, the drought. We've seen the Lepidoptera that we've talked about today. And now ticks, we're seeing at least animal ticks, not human ticks, human-related ticks are now occurring in Alaska. Now, kind of want to summarize here. This was just published by Sarah Yoder and Joe McLaughlin. He's, again, our state epidemiologist. So this was just published, an assessment of the potential health impacts of climate change. Now, the darker color means the magnitude and timing is high. That's the highest. And they're saying less than 20 years. And you could really kind of say right now. So let's look at some of those things. Increased solastalgia. That's a new word for me, but that means fear of loss of your environment. That's what that word means. Anxiety and depression. You have increased heat stress and associated disorders, increased accidents due to infrastructure damage, increased accidents due to wildfires, increased accidents due to weather change, such as flooding, increased accidents and injuries due to unsafe ice conditions, increased exposure to hazardous materials associated with infrastructure damage, increased morbidity and mortality related to food and waterborne diseases, and increased morbidity and mortality due to compromised access to safe water and sanitation facilities. So those are the ones that are imminent or occurring right now. So this is, as I mentioned when we first started, we're not looking forward to looking ahead to climate change. We're looking at climate change. And I've tried to touch on some of the health impacts of climate change. I know it went through it pretty quickly, but you can look at things like the poor water quality, respiratory illness, hazardous injury related to ice, unsafe food, drought and infestation, snow hazards, allergies, dangerous seas, wildlife disease, infrastructure damage, food spoilage, allergic reactions, food insecurity. And I think that's central because that's going to really impact the way of living and of the native population. And without a doubt, I'm not going to call the native population marginalized individuals because they're not. They're really central to Alaska, but because they live almost exclusively on subsistence life, this is being immediately impacted right now. And then also, and finally, mental health and solastalgia. So with that, the Arctic, our window to the future. Now, with all these things going on, Alaska remains a beautiful, magical frontier. And I love every day that I'm here. And I hope you all have an opportunity to come and visit. So with that, thank you very much for this opportunity. And there's my email if anyone wants to contact me. Thank you.
Wow, thank you so, so much for your presentation today. I know we gave you a very difficult assignment request.
That was big.
We said, can you summarize all the different health impacts and environmental changes going on in Alaska in an hour to an hour and a half? To which I can only say, oh my goodness, thank you so much. I'm in awe of the breadth of your presentation, and it is just remarkable to look at all of those different impacts and have it all condensed into one really powerful and impactful presentation. And to note that these are the things that are currently happening, currently being observed. This is not modeling. These are not projections. These are the things that you're currently observing in Alaska. So thank you so much for sharing.
You're very welcome. You're very welcome.
So a quick question for you. How do you feel about the reaction of the allergy professional organizations in terms of centralizing these issues?
That's a good question, and it's kind of been one of my drivers. I was the first to actually present climate change to one of our international meetings. And honestly, since then, we've had, that has been part and become at least there's going to be one symposium on it every year at each of our meetings. And then the regional meetings, I'm commonly invited there. But it's not been embraced as much as I think it should be. The answer is yes. It's been I think people realize it's there and are cognizant of it. But the question is, what do we do? And so I think there's greater observation now than there was in the past that this is occurring. And, not every area is going to see those impacts right away. I think one of the biggest impacts we are seeing are these prolonged pollen seasons. And studies have been done. There was a beautiful study done in Italy over a 27-year period that demonstrated with more and longer exposure to pollens, you have a significant increase in the number of people that develop allergies. And they correlate, their control was like dust mite allergy. That hasn't changed. So over 27 years, there's a very significant increase in people with ragweed allergy. It wasn't ragweed, it was paritaria, but with that kind of allergy and olive allergy. But there was no change in dust mite allergy or cat or dog allergy. So you're seeing more people becoming allergic is the point. So not only is it more severe, not only is it more prolonged, but it's impacting more people. So greater numbers of the population. And then, in some of these areas like Australia and New Zealand, you're looking at 35 to 40% of their population has asthma. I mean, so in some of these areas that are more significantly impacted, you're also seeing more respiratory disease as well. So
Right.
I think there's an embracement of that, but there's also a feeling of what can we do about it? What is there to do? And
Right.
that's sort of the frustration. So education is the most important, and we already do that. A big part of what an allergist does is educate. How can you minimize these exposures? But that's a really good question.
Right. I think the other thing I saw in one of your papers was, basically reference to the adjuvant effect of fine particles, and particularly PAHs and other particles of incomplete combustion.
Right. Yeah, that's very significant. And in looking at that, there have been studies that looking at where someone lives near a state highway or a federal highway is really a good example of that. So the closer you live to a larger highway system, the greater the higher the probability of respiratory disease and the greater severity of respiratory disease. So looking at these particulates that are being released, these gases that are being released, have direct impacts without a question on respiratory health. And now we're seeing more and more impact on cardiovascular health as well. So we don't really think about that, but these things are being inhaled and they're being internalized. So it's not just a matter of that immediate effect of the respiratory event. It's also the internalization of these pollutants that can cause a problem as well. So yeah, that's a really good point. And we talk about that aggregate effect with the pollens where they bind together and that drives it even deeper. So good point. Yeah.
So Michelle, do you have any questions that have been typed
Yeah.
in?
Oh, absolutely. Yes, we have a few. First, you mentioned that some communities are, either relocating or considering relocation.
Right.
Will the federal or state government be providing assistance to some of these communities, or is it kind of on the communities to find the support themselves?
It's a combination, but yes, there are 6 communities that have been provided funding so far. 2 of them have been provided, like it's about $50 million each to relocate. Another 4 or 6 have been given grants to go out and study it. So that they're funding the studies of how we can do that and where can we go. So the answer is yes. As far as in addition to the federal grants, the native corporations are really quite robust and they have funds as well. So the native corporations are also funding some of that. But I think I wish money would fix it, but it won't. I mean, this is because not only when they're moving, they're leaving their ancestors, they're leaving their artifacts, they're leaving their native soil, and it's really having a significant impact. And Dennis and I were speaking earlier. I mean, what's happening in some of these areas, they're leaving the village. And when they leave the village, they leave a subsistence lifestyle and they enter a Western lifestyle. And they're really not very equipped for that. So we're seeing significant levels of diabetes, heart disease, obesity. So this is not a very good situation. Because their entire, all their ancestors have been subsistence livers, and their diet is completely different. There are no Kroger stores out there. And if they have little community stores, but if they want a gallon of milk, it's $20 a gallon. So they're not buying a lot of chips and soda. They get some, but the kids may have a treat, but they're truly living off the land.
Oh, thank you. We have another question specifically around the intersection of Alaska's aging population and some of these issues you discussed. Noted that the 60 plus population has increased by 62% between April 2010 and July 2021, and Alaska's 85 plus population has increased by 87%. So how do these issues that you've been talking about kind of intersect with that aging population?
Well, that's interesting. And when you're looking at the percentage of the aging population, there's a couple of components there. Number one, I think there are people that are retiring in Alaska, but what's also happening is we're losing young people. So we've had an outflow of a younger population because there hasn't been enough job opportunity, or they're leaving, they're going out of state and going to college, and then they wind up with a job in Boulder or a job in New York or a job in California. So we're losing younger population. I think that may be a reflection of the more aging percentage as opposed to more aging numbers. But now on the flip side, data has clearly shown that living in a colder climate, you live longer than somebody living in a humid, warm climate. No offense, California, but that it was some interesting data, and it showed like an additional 4 years. So I think people in Alaska, even in their elder years, are engaged and they're very active. If someone is not engaged and connected to Alaska, they're probably moving. We stay here. I mean, I'm gonna put myself in that category now. I'm moving into that. Well, I probably am there, but it's not a spectator sport. You've got to be involved and engaged. So I would say that it's probably a matter of maybe living longer, and more people are here because they want to be here. They didn't just come here to work. So a lot of people move to Alaska for the pipeline and for the oil industry. Well, that part of Alaska is not as robust as it used to be. So they're moving out, and they may not have been lifelong Alaskans. So there's a difference. So I think there's probably a multitude. Now, to answer your question, how does it affect the older population compared to the younger population? That's a really good question. I don't have an answer for it. I think the older population probably recognizes these changes because they've been around long enough to see it change. So it probably has more mental health impacts, where maybe a younger person, that's just the way it's been, and may not have the same mental health impact. I could see that as a problem. So elders are definitely going to be more aware and cognizant of what's going on and how their lifestyles are changing. But other than that, I don't know. I can't speak really to better or worse health.
Thank you so
But
much.
I rambled around a little bit anyway.
No, I think that context is really helpful to kind of understand the statistics. Another question specifically around insect stings. In areas with
Mhm.
significant increase in insect stings, how has care been provided for that increase? Are you aware of employers taking means to protect their employees from insect stings? Is there any involvement with private industry? Anything that you might be able to share around insect stings would be great.
Yeah, interesting. Now, again, Alaska is a predominantly outdoor kind of state. So when people are working outdoors, whether it's with the park system or whether they're surveyors or whatever they're doing, they're going to have more and more exposure and become more and more aware. So it is recommended that they're not out there in a sleeveless shirt. They should wear long sleeves, and they should wear a hat and wear shoes. I mean, so they need to have appropriate equipment. They're not going to wear bee suits, but they are aware. And as far as what is available from a health perspective, that is limited. There's only four. Let me see. Yeah, there's 4 communities in the whole state that can address insect sting allergy. Now, anyone can deal with the immediate event of anaphylaxis, but insect allergy from these stings is curable with 95%, 97% curable. But the access to that care is only in 4 different communities. But in Alaska, it's not unusual to get to a bush plane, fly to an area that has a 737 or a bigger plane, and then fly into Anchorage or fly into Fairbanks for care. So that's pretty normal in Alaska. So people flying in for those reasons, for any health reason that's beyond the level of primary care, that they're going to have to travel. And predominantly the travel is going to be to Anchorage, where we have the 2 tertiary hospitals, or Fairbanks as well. Fairbanks has a pretty robust specialty care access as well, not to the level of Anchorage, but so that system is in place. I guess I would say that. And if someone is recognized to have insect sting alert allergy, you know, EpiPens are provided for them until they can be assessed and treated.
Thank you so much. Another question that came in, are there preparedness or resilience projects that are going on to help empower the communities to deal with all of these challenges?
The answer is yes. I'm not currently engaged. There was one time I was on one of these councils. I was working with the sub-cabinet of climate change on climate change, and we worked for 2 years and actually developed a plan for Alaska. It was in 4 volumes, actually quite robust work. Each of our groups had a leader that was a kind of nationally renowned leader that was our facilitator. And we did a lot of work with that. Interestingly, that was when Sarah Palin was our governor. And, you know, so we developed this plan and we submitted the plan, and nothing really happened, but we developed a plan. And this is going on now. And Joe McLaughlin, you saw that last slide that I had, that's kind of part of what they're doing now, is going back and reassessing that and developing you said it well, a resiliency plan. What can we do? A lot of what we're doing in Alaska is going to be adaptation and education. Certainly there's guidance on what can we do to decrease our footprint, but you know, our footprint's fairly small. You know, we're not pumping out industrial gases except for the petroleum industry, which is quite significant, of course. But when we look at, you know, what can we do, the vast majority of greenhouse gases come from the development of energy. So, you know, electric cars are not really feasible in Alaska, but even if you have an electric car, you're using energy. So you still, you know, it's still greenhouse gas. But there, you know, there might be 4 charging stations in the whole state, I think, but they're not very feasible up here. But the hybrids are a great idea. I mean, so whatever we can do to decrease our footprint is good. I mean, recycling is good. You know, minimizing the use of chemicals that are going to contribute. We looked at what happened with aerosols. We took away chlorofluorocarbons, and you see that the aerosols actually had a favorable effect on temperature and climate. So I think we all need to do what we do. But is there a plan? Yes. Is there a lot of activity with the plan? I would say no. I mean, it's not like, our governor, has not, that is not one of his platforms. Let's just say that. So, we certainly have local and we have groups that are involved in development, but how much of those plans implemented, I'm not so sure.
Thank you so much for providing that information. I want to pass it to Dr. Schusterman if you have another question you'd like to ask.
Not I.
Okay, great. Another question, does the warming of the permafrost expose present-day organisms to ancient pathogens?
That is a really good question. And actually that topic came up discussing that. That is a really good, and I don't have that answer. I should, but that was actually discussed. I remember a discussion about that. I don't have the answer, but really very interesting. In fact, I'm gonna write that down. I'm gonna check on that, but I don't have the answer. I apologize.
No, that is, you've got a lot of information. It's okay if you don't have every single answer. So thank you so much, but thank you for that question as well.
Yeah, I'm gonna check that out. I'll contact Joe McLaughlin today.
Yeah. Another question, someone commented, they've heard that paralytic shellfish poisoning is rising along with other issues related to harmful algal blooms. Is this a major concern in the coastal areas?
Yes. That's an easy answer. Obviously that's not just occurring here because we're seeing that too. But it's definitely becoming a problem in some of the more southern tidal regions. Florida has been devastated with that. But we've had that problem in our well, along Cook Inlet, the Cook Inlet, and then further down on the Kenai Peninsula where there's a lot of clamming. So we're seeing that there as well. So yes, the answer is yes. We're definitely seeing that throughout the world, I think. And I think that's going to continue to increase with the increase in warming waters.
Well, and that ties directly into one of our other questions. It's just likening, in the news, Washington and Oregon, we've saw a lot of news around marine heat waves, with millions of coastal species experiencing massive die-offs. And curiosity, has Alaska experienced similar extreme marine heat waves as we've seen in some of the lower states?
The answer is yes. And we've certainly have had significant die-offs. We had die-offs with whales, with some beluga whales. We've had die-offs with seals, significant loss of seals, the spotted seals in particular. We had walruses that were dying. And part of that is because of the fact that they don't have the sea ice. So they're actually kind of now using land to be on and rocks rather than ice. But so there's a lot of changes. We've had bird die-offs as well, and they're trying to understand that. So the answer is yes. We're seeing with these changes now. Part of it could be the acidification, but there's a lot of thought that it's more the warming waters, and another part is starvation, because as these waters change, the plankton or other foods, like the krill, will move, and suddenly there's no food. So the fish follow the food, and so if suddenly there's not enough fish, but they don't really leave their environment. They stay. Mammals are going to stay pretty much where they've been, and they starve to death. So the starvation is felt that is playing a major role. Because when we're talking about loss of Yukon salmon, well, the salmon aren't in the salt either. They're just not returning. So yes, I think there's also pollock is a major fish, and I showed you on that one graph that the pollock, as well as many other species, halibut and snow crab, are moving 50 to 150 miles away, and as they move, you're going to have less nutrition for the sea mammals.
Thank you. And also, it sounds like more extreme conditions for the workers who go out and fish these different animals as well.
That's true. It's become very, very hazardous because in order to get to the sea ice, now they have to travel, and they travel in small boats. They have to travel, 50 miles to get to sea ice, where before it might have been a mile offshore or even closer. So, because without sea ice, they can't harvest, they can't hunt. And so they're hunting, again, they're also all regulated. They're not sport hunting seals. It's only what is nutritionally needed and for them. But they'll hunt the sea mammals because they eat seal and they eat walrus and they eat whale. And without sea ice, they can't. So that's creating a much more hazardous situation if you have to go 50 miles into the sea in order to get to the prey that you're looking for subsistence. Yes.
Wow, absolutely. Another question related to wildfire exposure, smoke exposure. 1,000 parts per million plus is quite an extreme. I'm thinking of our local AQI that's like 300 to 500 is the
Yeah.
extreme danger warning zone, and we're talking about 1,000 parts per million. Um,
Right.
are there any safe buildings for folks or refuge areas that are filtered air quality? Are there kind of any resource centers where people can go in those very extreme days of poor air quality?
Yes, that's a good point, and the answer is yes. They do have environments that have very robust heat circulation or air filtration that's available. Um, yes, so that does exist in it, but it's going to exist in areas like, communities like Fairbanks with the university. It's going to exist in Anchorage. It's going to exist in Juneau, but it's not going to exist in Nutuk. It's not going to exist in Kaptuluk. So in these smaller areas, the only thing they really have is a school. So the school is going to be kind of the community congregation in an event like that. And the schools they're going to follow regulations. When they're built to the same regulations the schools in Anchorage are built. So they're going to have some type of HVAC and filtration system available. So that's going to be probably the one draw. But some of these villages, there's one school that's shared between 3 villages, and it's going to be and the kids have to travel, or sometimes what the kids do during the school year is they stay with a guest family during the school year, and then they come back on their snow machine, for breaks, or they come back on their on a boat for breaks, because it might be as much as 30 miles away. But so in those communities, no, there wouldn't be probably any resource if you don't have a school.
Thank you. On the same, I guess, wildfire thread, a question around burning tundra, and the note that it will smoke for years, and some curiosity of like, what is the mechanism in which the tundra will continue to smoke for years after
Well,
exposure?
it's just underneath. It's kind of like burning peat. Think about, it's smoldering peat. So, the tundra, it's layers of vegetation. And then you kind of add to that, and I don't know how much it plays a role, but methane is quite combustible too. So it just kind of sits in that ground, and it's just like coals sort of burning, and smoking. But it can go on for a couple of years. Not for dozens of years, but a few years. It can be a problem. But I don't know if methane plays a role with that or not. I'm thinking probably not, because methane is more combustible. So I would think about burning peat is how I would view it, and it just kind of smolders below, and the ground is damp, so it's not going to. It usually doesn't blaze.
Got it. Thank you so much. And we are nearing our close. Dr. Schusterman, did you have any final questions that you'd like to ask, or any final comments?
Not really, although talking about methane, I remember watching a documentary while flying across country, and these folks were going out in Arctic area. They were poking holes in frozen ponds, and they were able to combust the gas that escaped from those ponds. So I think that, the fact that methane's being evolved by the permafrost or tundra is probably a contributing factor, maybe, to its combustibility.
Right. I would think so as well. Yeah, that's pretty interesting. That's sort of a favorite pastime. It's to go drill a hole in the ice and then set it and light it. So you really like a blowtorch coming
It's
out.
like a blowtorch, right?
Yeah, it's pretty impressive. Well, that's I almost put a picture like that in there, but I said, oh, no, that's a little too corny. But I'm glad you brought it up. I'm glad you brought it up, because that is true. That's real.
All right. Well, I think that's a good closing point for our discussion today. And really appreciate you're totally up to the challenge. And I think that you have a new set of followers in Northern California now.
Well, it was a lot of fun. Maybe I can come back and talk about respiratory disease or something in climate. Then we get into the weeds, so to speak.
There we go. Okay.
Well, thank you very much. It was a wonderful opportunity.
Thank you so much for presenting. And just a note for our audience, I put a link in a chat. We have another climate change talk coming up on Wednesday, April 10th. So if you're interested in learning more, you can check out that talk as well. And thank you so much, Dr. Demain. I learned an incredible amount during your talk today and really appreciate your time.
It was my pleasure. Thank you.
Okay, bye guys.
Have a great day, everyone. Thanks again.